All right, folks, let's get going. So we talked about passwords and how to save them, and that's just one part of the credentials we'll be saving. All right. So I wanted to get that kind of technical discussion out of the way first, so it doesn't distract from the next thing we want to talk about, which is going to be about users. Now, I gave you a video and a quiz. I hope you did both. Okay. Look, that's not a good sound. So there was if you looked at Canvas, there's also a quiz for this week. All right, and the video is called User, and it makes a provocative point. What's the point? And what is the concept? What is the wrong concept we have? What is the right concept? Right, right. Yes, 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 yes. Great. So we think of the user as something within our system, and they're not really in our system at all. Are they? Otherwise, we don't need a system. We can just talk to them. All right. Um, so first of all, the video is by Avdi Grimm. He's well-renowned person in the Ruby community and quite a bit in the general programming community. He's most famous for this series called Ruby Tapas, where he produces a video every week on not just Ruby, but on many concepts of architecture and programming and things, but mostly in the Ruby language. And this is one of his excellent videos where he kind of just takes a provocative look at some things we take for granted in computing. All right. So let's start. So thank you, Edgar, for that description of how we are perhaps wrong about how we model users. Okay. So let's take this word user. There is one of the things that, let me preface this by saying I'm not young anymore, and I've been coding for a long time. And one of the things that becomes clearer and clearer to me the longer I've been coding is that there's a joke in programming, which I'm beginning to think is not a joke at all. And the joke is something like this: it's not a joke; it's just a saying. There are only two hard things in computer science. One is cache invalidation, and the other is naming things. If you're a programmer and you've dealt with caches, you'll know that this is a tough problem. You cache some data. How do you know how long this data is valid for? When a user wants it again, do you just give it from the cache again? Or is the data expired? Like, it's a very difficult problem to deal with. So everyone understands from a technical perspective that cache invalidation is a difficult problem. It's obviously not the most difficult problem, um, but hence the joke. The joke is kind of saying there's two difficult problems: cache invalidation, just to give you a technical example of something that's difficult. And the other example, the other thing that's considered difficult is just naming things. Giving names to objects is considered extremely difficult. And why is that? And hence the joke. Some people, when they first hear, they say, oh, haha, yes, naming your object is a little bit difficult. The longer I've been coding, the more I realize the joke's on us. Naming things is actually incredibly difficult. And it's also at the heart of a lot of problems that we introduce by ourselves in computing. All right. When we misname things, we launch ourselves off in a wrong direction. And a possibly great example of this is user. All right. On the one hand, when we talk about user, it's a really nice catchword for that person at the interface, right? The user. Like, if we have a name for all of them, generically, of whether we're making an e-commerce system, an email system, a Bitcoin system, we can call all these people users. So it's become a generic word for the customer or the person we're serving using the systems we're creating. All right. So why is it a problem? Let's first of all, let me get a little philosophical about why it's a problem. Okay. Let's talk about object-oriented programming, because we're doing object-oriented programming in this class. So there is a notion that is sometimes fed to students by professors, sorry, um, in your early classes in computer science, that somehow object-oriented programming is amazing because the world is made of objects, and so we can represent the world in using object-oriented programming. You've heard this before? And this is, I think, something only professors say because I don't hear industry people saying this. And I think professors are saying it maybe because, I don't know, maybe for many reasons. It's a simple explanation. It's a great beginner explanation, and it's a friendly explanation, but it's a simplistic explanation. Um, Object-oriented programming is not really made for modeling real-world things. Okay, real-world things are people, cars, buildings, etc. Um, in fact, typically when you look into a system, like if you look at your own code today, you will not find very many real-world objects. You may find a few, but the vast majority are not. The vast majority of the classes and objects you're making are like object relational mappers, web applications, controllers, data models, etc. JSON objects. These things don't exist in the real world, right? And in fact, one of perhaps the key founder of object-oriented programming, Alan Key, um, said that maybe the biggest mistake he made in inventing object-oriented programming was to call it objects, because then people start thinking about objects. And really what he meant was stuff, things, just anything that is important to you as a programmer, but not real-world objects, okay? Any concepts that are important to you as a programmer are objects. It doesn't have to be real-world objects, and in fact, it probably shouldn't be real-world objects. And Avdi, in his video, makes a really great point that we don't want objects of people because people are complicated and we're not modeling complicated people. We're not modeling cars. We're not modeling buildings. We're maybe modeling the data for those things, but we're not modeling those things. All right. And in fact, we shouldn't model these things because they already exist. We don't need to make a computer simulation of them if they already exist. So objects are used to model how rules of business or your whatever operation you're running, it may not be a business, maybe some other kind of service, how the rules of your service apply to certain facets of the real world. Okay, so like I said, most of the objects you're going to make have no bearing on the real world. They're like controllers and this and views and stuff that doesn't exist in the real world. If you are modeling stuff that sounds like it exists in the real world, it's probably still not the same thing. What you're probably modeling is stuff that helps serve somebody in the real world. For example, in an e-commerce system, you may have an object called an order, right? What is an order? Does it exist in the real world? No, it doesn't. You can't walk around and find orders. What you can do, though, is an order is kind of a representation of what somebody actually wants you to send to them, okay? So it allows you to have a place where you can add items to a shopping cart. It allows you to apply coupons and codes and discounts. It allows you to compute things like total values. So the reason we create an order object is to have a place where all this different logic can be at home, a home for all this logic, right? So that is an order object. We have an invoice object. Now, you have seen an actual invoice, right? Like somebody can print out an invoice, right? An invoice is often typically things you're going to be billed for. So somebody can print out the invoice, but what we are modeling in our computer, in our e-commerce system, is not the printout. We're modeling everything before that printout actually happened. We're modeling the actual details, right? And of course, our object could have a method to say, can you please print this out? But we're not modeling a piece of paper, we're modeling information. The fact that it can be a piece of paper is fantastic, and it's external to our system. All right. So objects are rarely ever representing real world things. They maybe represent certain facets or certain aspects of some real world things, limited aspects of real world things. Okay. So users, what's in a name? why not just call it user? So Abdi makes the point that in this system we're making, and this is a simplified view of our system, it will get more complicated before the semester is done, probably. The only entity here who's actually talking to a user is the browser, right? Nobody else is ever talking to a user. They're modeling users, which is really weird because they've never seen one. Like his story about the little robot running in circles on the moon, on Mars? Where was it? I forget. What's that? And on a space station. Yeah, on a space station. Yes, thank you. So since the browser is the only one who talks to users, why are they so concerned with users? In fact, the API should be concerned about the web application because that's who it is serving. It's serving a web application. Why don't you just focus on serving a web application? The web application is serving a browser. It's literally called a web server, right? Not a user server. Now, the browser does talk to a user, but now here's an interesting thing. The browser actually doesn't talk to the user. The browser gets inputs that come from the user's fingers touching something on a keyboard. There's several layers of indirection. The browser isn't like good friends with the user. It's an indirect tool. The user touches the keyboard and the mouse, or maybe some video related thing, and then the browser gets that sensory input, and then it infers what the user wants to do. So even the browser doesn't actually talk to the user. Nobody talks to the user. Nobody likes the user, okay? So it's a little unusual that we have systems that pretend that they understand the user. We don't, right? So when we use the word user in our system and we make a database table called a user and we create objects called user, it implies we're modeling people when we're really not modeling people, right? And particularly our API is not even a user of our API. Like the person we're thinking of as a user doesn't actually even use our API directly, all right? And there are other problems. The person you're calling a user could exist twice in your database because they may have two separate accounts. I have at least 2 or 3 Facebook accounts. I have at least 5 or 6 Gmail accounts, all right? And why do I have them? Because when I'm using Gmail for personal reasons, I use one account. When I'm using it for work, I use another account. When I'm using it for my general academic presence in the world, I have a completely different account. So one for my personal life, one for NTHU, one for me, the professor in society. All right. And I have yet other accounts for things I will not tell you. Okay. My superhero account is like, all right. So first of all, the accounts you're creating don't even correspond necessarily to actual users. I had this kind of a great discussion with a company about this, where I seem to have the same discussion with every company I talk to, but I had a discussion with them where they were like showing us some data, and they were telling it, yeah, you can see this users or it's this users, blah blah blah, and they're showing us all the database records and all the information they have, the data they have on these users, and they're like, yeah, these users come back this many times, these users don't come back that many times, these users come back a lot, and I said, oh, interesting, and I was buying all of it, and then I went, wait, hold on a second, I use your app. You don't even have a login feature. How do you know who your users are? And because literally the app does not have a login feature. And I'm like, you just like open up the app and you use it. And I'm like, how do you know who your users are? And they're like, well, based on what device they're using. And I was like, wait, hold on a second. The app that you're making is like a really fun app. It's something between productivity and entertainment. There's no reason for one person to use that device for this purpose. Like if it's on an iPad, maybe it's sitting in the living room and everyone is coming and using it for this purpose, right? Like imagine you have an iPad and it's in your living room. Like, kids could come play with it, you could come play with it, your visitors or guests who are coming to your house could play with it, to watch YouTube. They're not the same user. So it's not even the same person a lot of the time, all right? And even if it is the same person, what happens when they change devices for that company? They change devices. Is it a new user? Is it the same user? These aren't So you see, like, there's a big disconnect between what the company's calling user and what like the data is actually contains. And I pointed it out to them. I'm like, actually, like if a person updates their phone every 2, 3 years, buys a new phone, which a lot of people do, there are going to be different users in your database. They're like, oh, yeah, 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 that's true. That's kind of true. I said, yeah. And if they leave the device and their family likes to use it, then it's not even the same person for the same account information for the same device. They say, yeah, 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 that's also true. And they agreed to all this, and then we continued talking, and the language changed a little bit to like, yeah, well, certain devices, can we use devices? Okay, certain devices are doing certain devices, certain devices. And then after like 10 minutes, devices, yeah, 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 these belong to users. Users, and they just fall back into talking about users. And it's the deception we've played on ourselves, where we called it a user, and now we can't get away from it. Even though the data absolutely does not reflect users, all right? That's why naming things is so incredibly difficult and why it's so incredibly dangerous. You misname it and you've launched your ship in the wrong direction. And it's very hard to change course after this word is also conflated with your marketing terminology and your management terminology and your HR terminology. It becomes a big mess. All right. And you can't really work your way backwards after a certain point in time. Facebook is currently under a massive class action lawsuit, again, for this mistake. They've been telling companies who are advertising on Facebook that we are an unusual company because we can actually tell you about distinct and unique users. Until a couple of months ago, some weeks or months ago, companies figured out that they're being billed for people who are not even users. Some of them are bots. Some of them are conflated between multiple people. It's not at all what Facebook told them they're paying for. And they're so pissed now, there's a massive class action lawsuit against them to say, we're paying for you for not what you advertised. Yeah. You in particular? Oh, if you don't call it user, you're fine. Promotion, yeah. So so this is the danger, and even after Facebook and the reason they're under a class action lawsuit is not because they made a mistake, is because investigators dug into the records and found that internally Facebook had been warned by its own employees. These are not users. Some of these aren't even people. Some of these are bots and other crazy agents running around the internet. Like there's other things than people on the internet. And but Facebook was so sold on the word user and so sold on its notion of a customer, the top management could not change its perspective. And chances are they're going to pay out a lot of money for this problem now. All right. Chances are. I don't know. It's up to a court, not me. So are we measuring people? I don't think so. People have feelings, people have family, people have faith, people have all kinds of things. We're not measuring any of these things. We're measuring, we're asking them for a name, which may not even be their real name, right? Um, and an email address, which they might share with multiple people. We don't even know. We're not modeling people. And we shouldn't get into the business of misnaming things because we end up fooling ourselves in the end. What we are modeling with usernames and emails and passwords and whatnot, we're modeling an aspect of people, not the whole person. And that aspect we're modeling is not something that exists in the real world. We're modeling a user's account in our system. Okay? And therefore, let's call it account. That's Avdi's argument. Let's just call it account. All right? And because if users don't exist, shouldn't model it. Users are not tangible. We cannot query users about a lot of things we want to know about them. So there's no benefit in modeling them, right? Whereas account accurately describes a combination of username, password, email, and certain attributes or behaviors associated with that behavior. Okay. So we can have accounts We could also have other objects that represent people or aspects of people, like customer. Maybe if you're making a visual design software, maybe you want to have an object called artist. That's not the whole person, it's an aspect of them, which is an artist. An artist has a portfolio, right? Like, that's true. But you don't want to maybe call them person, because person has other things. They have dogs and cats and spouses and kids and things that you don't care about, perhaps. All right. So we can model what we call users using multiple objects. There's nothing wrong with that. But one of those basic objects should perhaps be an account. And it's fine if every artist has an account, if every customer has an account, right? And it's possible that a customer can have, that one account can belong to multiple customers. Look no further than Netflix, right? When you get into Netflix, I'm assuming you are all sharing your account with somebody, or you're sharing somebody's account. We know this, Netflix knows this. So when you log in, it doesn't say, "Hi, Edgar." It says, "Who's using this?" Is it Edgar? Is it the kids? Is it the wife? Is it relatives? Like, who are you? So you can create multiple profiles in Netflix, because Netflix knows it's not always the same person. All right. So at least they're smart enough to say, "Who are you? Be honest. Who's this?" And even that is a good guess, because honestly, like, I was using Netflix in the US and I forgot to log out of my landlord's device, and I came back home and my landlord was using like a Roku device and he couldn't figure out how to log me out for 3 or 4 solid weeks, or maybe no, for 1 or 2 solid months. He and his girlfriend used my Netflix accounts. So if Netflix is like, "Wow, Somya is into like a lot of different stuff," it's because the Somia account is not me, all right? Even the Somia profile is not me, all right? So it makes me mad when I log into Netflix and I like look at my recommendations and I'm like, why is it recommending a romantic movie? I'm like, "Honey, what the hell have you been doing with Netflix?" And I know my wife has gotten into my profile, all right? Or was just too lazy or didn't notice to switch profiles. So Um, we're only for now modeling accounts, let's call it accounts. If later you feel there's behaviors not related to account, bigger behaviors that reflects your user, then think carefully again, who is it that you're modeling, all right? And I would say even then, resist the temptation to call it user. Even if you say like, yeah, um, the user is now creating like a digital wallet and this and has purchases, so it's not no longer an account, it's a user. Even then I wouldn't say it's a user, maybe it's a consumer, right? Think carefully about the word that describes the behaviors you're capturing. You will do yourself a great favor in future as you're modeling the system, as your system gets bigger and more complicated, and as you do other things like data analytics and stuff on this. You don't have to tell your data analyst, "Yeah, this is the user." You can say, "No, no, no, this is just an account. Multiple consumers can use the same account. We also have consumer objects, don't worry." All right? So it will force you to model your data and the behaviors in a more accurate and helpful way in future. So I will take Avdi's account and I ask you to follow me on this journey, at least for this semester. When the semester's over, you can be like, back to user. It's like your life. But at least for this class, let's just stick to accounts. And if you have other behaviors that you think are bigger than an account, make a new object. No problem. There can be a one-to-one relationship between account and artist, consumer, whatever it is. All right? Okay. So accounts. The rest of this class is going to be a whole bunch of code. All right. So I hope you brought your coding hats today. So we're going to make accounts. Here's my migration for an account. All right. By the way, I had to completely renumber all my migrations and start from scratch because accounts need to be created before anybody else, because a lot of the other models depend on accounts. So I have to create the account table first. So accounts, it's a new type of table. It's a new table. It's got a primary key. associated with it. All right. It's got a username associated with it. The username has to be unique. Two people cannot have two accounts, not people. Two accounts cannot have the same username. All right. They may not be this. They may be the same person. I don't care. They have to have different usernames. All right. I need to have each account needs to have its unique email address. Why? Because something you have. All right. The email needs to be something unique that only you have, and in this case, it belongs to the account. All right. A password digest. This is going to be our salted, key stretched, hashed password. Something only the user, something only they know. I don't know it. And timestamps. All right. So that's it for accounts for now. It may get more complicated later. So in future, I can do things like this by making it a SQL. When it's a SQL model later on, I can do things like account.find username somia.ray. Given that account, I can set the password. I can then check the password. Is the password this? True or false? All right. Here's the model that lets me do all that. So this is the SQL model for account. In my database, every account can have one or more projects that it owns. It owns those projects. It's the project owner. All right. So there's a one-to-many relationship between accounts and projects. Notice now, unlike last week or the week before, this relationship is not as simple as, it's not just called projects. All right. It's called owned projects because I may be on projects that I don't own. I could be a collaborator on a project I don't own. So for a project that I have access to, I could either be an owner or I could be a collaborator. Okay. So I'm calling this owned projects, and this is going to cause a problem because I don't have any other class called owned project. All right. This really just corresponds to the project model in my system. So for this attribute, owned projects, I am explicitly telling SQL that the class, the model that corresponds to this relationship is the project class. All right. But within it, I'm going to call it owned projects. Within the account class, I'm going to call it owned projects, projects that I own. All right. And within this project class, the owner ID ties that class to this class. Okay. So earlier I was doing things very implicitly and letting SQL do a lot of magic to figure out which class and which keys to use. Here I'm doing it very explicitly. I'm telling it this own project belongs to that class with this key. All right. So this is an explicit way of doing it. And I'll talk about dependencies, but right now I'm telling it, if you delete, I'm using this plugin called association dependencies so that SQL, this model, can have this behavior. When you delete an account, you must delete all the owned projects. All the projects that I own must be deleted along with this account. Do not keep those projects around after this project has been deleted. All right. Also, an account can have many collaborations, and this is a many-to-many relationship. Collaborations means projects that I'm just kind of cooperating on. I don't own them, I'm cooperating on it, okay? I can have many projects that I'm collaborating on. A project can have many collaborators. Only one owner, but many collaborators, so this is a many-to-many relationship. Once again, I don't have a model called collaboration, so I have to tell it, when I say collaborations, I'm talking about this SQL model called project that I defined earlier elsewhere. All right. Now this is a many-to-many relationship, so as I'll show you in the following page, in a many-to-many relationship. So okay, first of all, accounts, and this is a database table view. This is the ER diagram. One account owns 0 or more projects. One account can collaborate on, this should be 0 or more, not 1 or more, but 1 or more or 0 or more projects. Okay. A project can have 0 or more documents. Now the key thing is account and project is a many-to-many relationship. And for that reason, it has to be modeled in the database a little bit differently. The ownership relationship is easy. Every project has an owner ID, so therefore you know which account it belongs to. But now for an account to collaborate on many projects and a project to have many collaborators, we need what's called a join table. And in the join table, it's going to be just another table. I'm going to call it accounts projects because it is a table joining accounts and projects. And it's going to be, every row is going to have a contributor ID and a project ID. So if a project has 20 collaborators, or excuse me, I'm sorry, this should say contributor. Excuse me, it should say collaborator ID. Okay. So if a project has many collaborators, then it will have 20 rows. All right, in this table, with project number 5, first collaborator, project number 5, second collaborator, project number 5, third collaborator, etc. It's a join table. All right. Okay. I'll get into this database stuff in a moment, but before I move away from the model, notice what else it has. I've made, so remember my account now has owned projects, which is going to be one or more projects that I own. It's going to have one or more collaborations, which is projects that I am collaborating on. If I want to get all the projects associated with this account, I'm making a method called projects. And projects simply takes the array of owned projects and collaborations and puts them together. Those are all the projects I'm affiliated with. Those are all my projects. Okay. Also, password is a little bit unusual because first of all, I don't store the password in the database. It's a password digest in the database. So I've made my own password function. So this way you can set a password to a new password. This creates a new password digest. If you want to check a password, try and see if it's the same, then I will use my password model that I showed you earlier to recreate the digest and check if it's the right password. And this returns true or false. Okay. Excuse me. Do not disturb. Forever. Okay. All right. And last of all, very importantly, I have my own toJSON method. And this obviously does not return the password or the password digest. Okay, it's everything except that. It's the I'm saying, I'm giving it a type. This is an account, an ID, a username, and email. All right, and that's my model for account. Again, for many of you, most of you, you can just literally use this exactly. All right. So this was the entity relationship model, and this is the physical database design. Okay. Let's talk about the associations in a little bit more detail here. So I'm sorry, this is a very messy slide, but let's work our way through it. On the left-hand side are migrations. On the right-hand side are models. Okay. So the account model. So I already talked about the account model. The project model is going to have to be changed as well because the project can now have many collaborators. That's something new this time that I didn't have before. And it can have one owner. Once again, there's no model called owner and there's no model called collaborator. So I have to tell SQL that these are the classes that I'm talking about the account class in both cases. All right. And for the many-to-many relationship, I have to again specify the join table, which I did previously when I defined the account. It's the same join table, right? So in the account view, the relationship is called collaborations. In the project view, the relationship is called collaborators because it's the actual developers who we are interested in. Okay. The only difference is apart from the name of the relationship, collaborations versus collaborators. The only and the class is going to be different. So that's pointing to class project. I'm pointing to class account from project. And the left key and the right key have to be in the right order. The left key is the key that belongs to this class. The right key is the key that belongs to the other class. Okay. All right. Document doesn't change because document doesn't belong to anybody other than a project. All right. You don't have ownership over documents, only over projects. In the tables in the database tables themselves, you will also note that this time I had to have a new migration, which creates a join table between accounts and projects. Okay, so it has a collaborator ID and a project ID. I don't have to say that this is a foreign key, blah blah blah. It's a join table. These are going to be obviously foreign keys. I just have to tell it which other table these correspond to. All right. So that's the join table here. This database table just to join those other two tables together. Project does need a foreign key though for its owner. Okay. And I don't believe documents did not change. Okay. So these are the changes I had to make to the migrations and models to fit accounts into this whole picture. Any questions on any of this? You're okay? I know code is not by itself, looking at somebody else's code is not terribly interesting stuff. Let's talk about some of the dependencies. I showed you earlier that in the account model, I had this dependency where I'm telling it, if you destroy an account, please destroy all the owned projects, not the collaborations, please. I don't own those, but all the owned projects, please destroy them. I've got a more interesting association now for the project module, because remember, a project has an owner and it has, this is configurations, you should read collaborations. Anyway, so a project now has I'm using this association dependencies plugin, and I'm adding two dependencies. One is on documents, which I had before. If you destroy a project, destroy all its documents as well. I have one more. If you destroy a project, nullify all the collaborations that are associated with this project. Let me talk about these two relationships. Again, configurations, this should read collaborations. Edgar! Please, all configurations should be collaborations should be collaborations. Thank you. Okay. All right. So I'm just saying when you destroy a project, destroy all the collaborators. Collaborations, excuse me, not the collaborator. Ah, this is going to be difficult. This is going to be difficult. This should be collaborations, which is actually, you know what? No, hold on. Oh, I've renamed all my from previous years. I've renamed everything. I'm so sorry. Configurations are documents. Yes, for me, not for you. Yes, stretch break indeed. Configurations of documents. Destroy all the documents, okay? By the way, you may be curious why I'm using the word destroy. Why not delete? In SQL, if I take a project, like I take the first project from my database, and I delete it, all SQL will do is delete that row in the projects table. That's it. If you want to cascade this to other tables and remove things or change things in other tables, delete things in other tables, you have to use the word destroy. So remember, if you're trying to delete an object from the database and it has dependencies that you also want to delete, use the word destroy. Destroy tells SQL, this is not just deleting one row, I'm going to now go through your dependencies and destroy the other ones like the documents as well. So I'm going to destroy your documents as well. All right? Whew. That was difficult. The next one is nullify. Now, this is a little bit more complicated because when you delete a project, I want to, of course, destroy all the collaborations that are happening around this project. So contributors is collaborators, sorry. All right. So what I'm telling it is nullify means the relationship is defined in a join table. please cancel that row in the join table. Do not destroy the collaborators, because those are accounts. Don't like get rid of accounts, okay? But just get rid of the join table. So nullify means remove that relationship in the join table. That's all. I made it. Barely. All right. Again, naming things is difficult, and over the years, over the past 3 times I've taught this class, I've used this same project. Before I was using a different project. And every time I teach it, I'm like, I'm not happy with how I've named it, you know? So I keep renaming things. Sorry, that screws up my slides. All right. So that's all the database and model stuff you need to know about accounts. Are you okay with this? Great. I'm going to show you some other stuff, and this relates to generic other things. It doesn't have necessarily. Oh yeah, question. What? Say that again. Ah, sorry, but not everything is free. I charge for this piece of advice. No, I'm using this is a Mac only application. It's like Visio, but it's for Mac. It's called this table of Macs is like. Oh, using Linux on your machine. I'm using something called OmniGraffle. OmniGraffle. It's like Visio, a little bit friendlier, a little bit nicer than Visio though. Okay. But nowadays, I find a lot of people are using like Draw.io and other things, right? So you're welcome to. And I think I shared in one of the channels, there's even a plugin with which you can describe your tables and in Markdown, or no, in YAML or something, and Visual Studio will generate like stuff for you. Which does anybody remember which? Maybe it was in the DB channel, in the first week's database channel. dbdiagram.io, but I shared also a plugin. If you scroll down later, later on I shared a plugin. What is it called? Yes. So for those of you using Visual Studio, there's something called ERD editor. ERD editor for Visual Studio. Oh, it's right here. It's right here. I mean, this allows you to draw tables, define things like this. Hurry up. And create relationships, all within Visual Studio. And it saves that all in a JSON file, excuse me, not in a YAML file, in a JSON file. What's the name of the plugin? ERD editor. It's only for Visual Studio Code, but whatever editor you're using, look around, there might be something. Otherwise, use Visual Studio Code. It's just where the bulk of this is where the momentum is, so to speak. Oh, Emacs version, nice. That's cool. All right. Yeah. All right. Moving on. Stretch break, really stretch break, because we're done talking about accounts for now, for the most part. Okay. I just have kind of restructured my code a little bit because it's getting messy. My controllers are getting messy. So I'm going to show you a brief trick that I also use in my SOA class. So for SOA students, use a familiar trick to restructure my code a little bit. So, oh, there's water damage on the roof. Weird. Yeah, not on the floor. Oh, I think I know what it is. The ACs are creating condensation, and that's dripping onto the ceiling. All right. Stretch, 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 stand up. I really recommend. And then the people watching this as video from home will be like, what the hell's going on? They're all like, but I'm still in bed. Do I have to stretch? Okay. All right. Stretch break is over. Let's get back to resume our painful positions. By the way, you're allowed to stand up whenever you want, as long as you're not blocking somebody's view. But you're allowed to stand up if it doesn't bother other people. Maybe if you guys want to stand up, you can just go to the back of the room and stand up in the middle of the lecture. It's totally fine. Okay. You can take your laptop and like stretch your legs and do whatever you need to do. All right. Cool. All right. I'm going to do a little restructuring. This is a very popular. I guess I'll call it a design pattern. It's a very popular design pattern. Some people hate it, some people love it, but I find it's useful, so I use it. Um, this week, I'm going to create a series of objects that I call, well, not just me, that I call service objects. Okay, and let me just show you what they do and why I didn't want to introduce this in a security class because it has nothing to do with security, but it really makes testing and coding easier. So I'm just using it for now. Okay. So I'm using service objects. These are objects that have some kind of side effect, like this, they change the world, like they change the database or they change the system in some way. And they perform some behaviors that I need in multiple places, okay? Um, so let me show you an example. I have created a service object called create document for project. This is a class. It has only one method. It can have more methods, but its important method is called call. And basically, you don't have to make an instance of this if you don't want to. You could, but all you do is say, create document for project dot call. It's a class level method, okay? And you give it a project ID and some document data, not a document you have not created yet. It's just the raw data for the document. And what this class does, this call method in this class, is it finds the first project that matches this project ID, and it adds a document to it with this data. That's it. All right. So this is all using SQL, right? So project.first.add document. All right. And I've just wrapped this up in a class called create document for project. Why did I bother doing it? This is literally a one-liner or a two-liner. Like, why bother creating a whole class around it? The nice thing about it is I can use it very easily in multiple places. For example, in my controllers, when you now post a new document, so project slash project ID slash documents, and you give me a JSON document to add to this project, all I do is I parse the JSON coming in, then I call create document for project, and I just pass it the project ID and the document data. And this creates a new document for me. And after that's done, I just do the other HTTP stuff that controllers should do: headers, status, location, etc., etc., etc. Yeah, question.
Wouldn't it be, well, would another approach be to overload the create method so that
I'm
in
not
your API part you don't have to?
okay. I'm not really overloading, because overloading means when you create another function with the same name as another function. I'm creating a whole new object called create document for project, and it simply does this whole business of finding a project, creating a new document, linking them together.
You know, what I mean is like, since SQL has a create method, right? The SQL.
Oh yeah, this add document is basically like create, but it creates it and links it with foreign keys to this project. This is SQL's own method, because SQL sees that every project can have multiple documents, so it creates an add document method. Okay. Yeah.
Can I ask?
Yeah.
SQL has the add function. How to like update one document who isn't belong to any project yet, but I want to link it with the project. Use something like add document. Is there?
Good question. So if you want to create a linkage that was not there before,
Yeah.
um, I think is it a one-to-one relationship or more than a one-to-many relationship?
One to many.
One-to-many.
Like one project need to like update
Uh-huh.
several documents.
Right,
because
right,
I don't know how to do that.
right. And you've already created the doc. You have to create the document in advance, right?
Yeah, sometimes.
Sometimes. You know, I don't exactly remember off the top of my head, so ask me on Slack. Yes, thank you. All right. So that's one place I can use a service object is my controllers. And I don't know, but I think giving it this word, create document for project, is a tiny bit more readable than these lines of code. Okay, a tiny bit, hardly. Okay, the real benefit comes that I can reuse this in other places. For example, in my tests, when I am like setting up my tests in my before block, I can quickly create projects and use this create document for project service object to just create, to populate the database quickly. So the one thing I want to tell you was about service objects. They're just, if you see them in my, you don't have to use them. I'm not going to grade you on your use of service objects in this class, but you will find as you look through my code, multiple places where I'm using service objects, and they are making my code a little bit shorter, a little bit more readable, a little bit more reusable. All right. Yenu, I don't know the answer to your question, but let me say this. What you're describing, again, sounds like a nice use of a service object because it may take a few lines of code to accomplish what you're asking, right? And if you have to do this in multiple places in your project, it would be nice just to have one name for this behavior. So that's the use of a service object then, all right? So, but I don't know exactly how to do it right now. I forgot, I should say. All right. So this week you'll see I've made at least 3 different service objects, and they're within a services folder within my app folder. All right. One is called create document for project. You just saw that. There's add collaborator to project and create project for owner. Um, okay. And so you saw create document for project. Create project for owner is similar. You give me an owner ID and project data, and I find the account and I add an own project to it. Add collaborator to project. Um, oh, Yenu, this may be what you're looking for. All right. It appears that add project, so these add objects, I think they can also take a SQL object. So you don't have to just give the raw data. You can actually give it a SQL record that you've already found. I think so, because that's what I'm doing here. If you'll notice, add collaborator to project. What is it doing? So for given an email address. Why? Because in my system, eventually, when you have a project, you want to add collaborators to it. I'm going to ask you, can you give me their email addresses? I will contact them and get them signed up and add them to this project. So what I'm doing is I'm finding an account with this email address, and I'm calling that collaborator. I'm finding a project with this ID, project ID. Okay. And I'm making sure that that collaborator you're inviting is not already the owner of the project. All right. You can't, I mean, it'd be ridiculous to invite the owner to the project they created. Okay. Then I'm saying collaborator dot add project, and I'm passing in Yenu. You'll see now I'm passing in the actual SQL object project. So it appears you can either pass in a hash of data or you can pass in an actual SQL object. Okay, and then I'm returning the collaborator object. All right. So all of these are service objects in that they tie together multiple models, they check some conditions, and they create certain side effects. In this case, they are altering my database. Okay. The next 2 slides, I don't want to really spend too much time going over. I just want to let you know that, because in case you look at my code and things look different, I have a much more extensive system now to put fake data into my test or development database. And I'm using this feature of SQL called seeding. And I'll give you the basic idea. So seeding means when you add data to your database. This is called seeding the database. Okay, and it's not real data. It's typically like fake data or some initial data that your database needs. All right. And in this case, I'll let you look through the code in your own time. If you want to follow this method, if you want to do what you're doing already to add fake data when you need it, it's totally fine. Okay. So I won't go over it in too much detail, except to say basically I've got a whole bunch of YAML files with a whole bunch of data, and I'm creating some loops to go through all of them and create to add more and more to add records. So for example, I loop through all the accounts and add those accounts to the database for testing purposes or development purposes. Then then for each of those accounts, I loop through all the sample projects. And for each of those projects, I loop through all the sample documents, and I just create this whole hierarchy of data in my database. Okay. That's all I wanted to mention. So I've got a slide about how to what that means. I'm not going to go over it right now because it does take away a lot of time, and you may not even be interested in it. Okay, but if your team is interested, and if you feel like, yeah, we do want to create a more extensive set of data, then maybe I'll meet with you separately to explain how I use this seeding feature. All right, if what you're doing already is not enough. Within my seeding code, I've got some interesting use of loops, which may look unusual, like this cycling code. And I've got a slide about cycles and enumerators in Ruby. Again, keep these as reference material in case you're interested in this feature, and then I can spend more time at some other point to describe it in detail. Right? What else is there? Accounts and controllers. So this week, I have some new accounts. I have some new controllers for accounts. So for example, I've got a get route so that for an account given a username, I can get some basic information on this account. Basically, I just find the account with that username and I return its JSON. All right. Or else I raise an account not found error. I have a post route to create new accounts. Notice I'm completely trusting. If you give me information about a new account, I'll just create it. In later weeks, we'll ask, who the hell is sending me this information? How do I trust that whoever is giving me this information is trustable? Like it's a web application, not some random person who found my API. Okay. So nothing too surprising. I'm getting the data as JSON is a posted information. I'm creating a new account with that information. If for some reason I cannot save it to the database, I am raising an error. Okay. And otherwise, I'm returning a 201. One thing you'll notice in a lot of my code is whenever I have a status code 201, which means I've created an object for you, I also return a header, an HTTP header called location, with a relative location to where that new resource is. So that way, when you create a new account, you're not like, okay, where is it now? Like you can do the HTTP response will literally have a location header telling you, oh, you want to look at that account? It's go here. Okay. This is considered a best practice for the 201 status code to always have a location header. All right. All right. And then I have a mass assignment restriction that I'm checking for, and that gets caught by, does account have a whitelist? I believe when I defined accounts a long time ago, let me see, where was it? Account has a whitelist. You can only set the username, email, and password. So the created at and updated at, you cannot touch it. Only the model itself can adjust those. Okay. All right. And what else? Excuse me. What other routes do I have? These are tests. So now I've got some tests for accounts that I can get the details for an account, that I can create an account, et cetera, et cetera. All right. So this week, all I want you to do is add accounts. Finally, add accounts if you haven't already to your system. Create all the linkages now between accounts and the other resources that you have. Okay. And of course, store the password safely. Not store the password, but hash the salted password using a key stretching algorithm, using the password and the modules I showed you earlier to create strong password hashes. All right. That's actually all I have for this week. So I'll use the remainder of the time to try to debug Yenyu's and the other team's issue. I'll do that live. All right. But to sum up, we have added a few more tools to our arsenal. So in the confidentiality world, your password is confidential because even we don't know what your password is. It's a salted hash using a key stretching algorithm. Yeah, we don't know what your password is. And in fact, let me just tell you something. Whenever you log into a website and if they have a feature like, oh, did you forget your password? We can email your password back to you. Run away. If they can email your password back to you, it means they're storing your password, which they should not be doing. All right. And if they can read the password, then they can lose the password. It's easy as that. All right. Um, I would also run away from places that say, huh, your password has like spaces. You're not allowed to have spaces in your password or some shit like this. Because that means they're literally checking the raw password against the stored passwords. If you're hashing, you don't care what characters are in there. As long as there's some kind of I mean, you don't care. As long as it hashes the same way twice, you don't care. So if you've come to a system where they're like, oh, you cannot use spaces in your password, run away. They don't know what they're doing. Okay. All right. Um, we've started the world of authentication, but we haven't really authenticated anybody yet by accepting credentials like usernames and passwords. And we have ensured the integrity of our database. So this is under data integrity by having association dependencies that are triggered by certain events. Delete a project, deletes the documents. Delete an account, it deletes the own projects, which deletes the documents. Okay, so there's cascading dependencies. Anything else? So that these are the things we've added, and trust me, we're going to jam pack this slide by the end of the semester. These are going to all be like 2 columns of stuff in each cell. Okay, we're going to have several more interesting things coming up ahead. Okay, I'm going to take the remaining time to try to debug Yenyu's issue, and I think there's a couple of teams. For the rest of you, it's up to you. If you want to watch me debug something, you're welcome to, which may be interesting as well because I may or may not be able to figure it out. But if you want to get some insights into how I debug stuff, you're welcome to watch. Okay. So first of all, can I use the Git repo that you shared? Can I use the URL you shared last time, on Slack?
You want to use it?
I'm gonna clone your repo.
Okay, now.
Is there a better time than now?
I mean, clone again. You go with update something.
Well, let me fix a problem in what you shared, because it's the same problem, right? Last night you shared a URL.
Yeah.
Can I use that link to clone? Okay. Yeah. I'm wondering if I want to continue the stream or not. This is a good question. Can I pause the stream? Yeah, there's no stop. There's no stuff. Let me try to do it. Yeah, let me stop the stream. Sorry to the folks at home. Bye bye. Okay, but that's it for today's lecture, and the rest is just going to be me debugging stuff.